here we're going to divide using synthetic division. How do I know when I can use synthetic division? If what I'm dividing by is just x plus or minus a number, so it can't be 2x, it can't have a squared, but if it's just x plus 6 or x minus 3 or x plus 100, doesn't matter if it's x plus or minus a single number. And so I start out by saying, okay, I'm going to put negative 6 over here in the box. So I always do the opposite. X plus 6, so I put minus 6, like what would make that whole thing equal to 0. So it's always the opposite sign. And then I just want to write down the coefficients from all my terms. So this is 2x to the third, 12x squared. Now be careful, notice how there's not an x here. You have to put a 0 because since I'm only writing down shorthand, like writing down the coefficients, if someone else came later and you didn't have that 0, they would think this is squared, this is x, and this is your number term. So you have to write them in order. That way later someone could come along and say, okay, well that must be the third term, x squared, this must be the x term, and this must be the number. So based on the number of them you have. So if a term is missing, that means it's like 0x. Alright, what's nice about this and makes it quicker is that you really only have 2 steps. Add and multiply. So add comes first, and so I draw this line under it usually to remind myself here's where all the addition's happening, and then the multiplication is everything is getting multiplied by this negative 6. So you won't multiply by anything besides this number up here. Alright, so first addition, see how there's 2 plus nothing, right? Nothing underneath that, so I kind of like use add multiply to also remind myself I start out by adding. So 2 plus nothing gives me 2. And now I'm to multiply. So 2 times negative 6 is negative 12. And now I'm adding again. So 12 and negative 12 add to 0. And now multiplying again. 0 times negative 6 is 0. And now to add, 0 plus 0 is 0. And to multiply, 0 times negative 6 is 0. And to add one last time, I get negative 1. Alright, so this is my answer, but I have to interpret what does this mean in terms of my equation. We'll see how this was the coefficient in front of x to the third, x squared, x, and this was the number. So all of these are coefficients on 1 degree smaller terms. So if this was on x to the third, this is now in front of x squared, this is in front of x, this is now our constant term, our just number, which makes this the remainder. If there's anything there, sometimes the remainder is 0. So I can write down my final answer and say, it looks like 2x squared plus 0x plus 0, so I don't have to write a bunch of plus zeros. And the remainder, what's the remainder mean? Well, just like in long division, it's the part that I couldn't get x plus 6 to divide into, and so the remainder is over whatever you were trying to divide by. Alright, so let's do one more of these, just because with all the explanation, it maybe doesn't look as fast as it actually is. Once you get a handle on it, it's actually a really quick method to divide. So negative x to the fourth plus 21x squared plus 18x plus 10 divided by x minus 5. So since it's just x plus or minus a number, I can use synthetic division. The opposite number, so if it's x minus 5, then plus 5 goes in the square. And now I just have to in order write down my coefficients from up here. So I have negative 1x to the fourth. And then be careful, notice I have no x to the thirds, and then I have 21x squareds, 18x, and then 10 is my constant. So fourth, third, squared, x, and then just the constant. Alright, so now we can do our add multiply steps. So add negative 1 plus nothing is negative 1, multiply by 5, 0 plus negative 5, right, add again. Multiply negative 5 and positive 5 gives me negative 25. Add again, I get negative 4, right? 21 and negative 25. Multiply, I get negative 20. Add, I get negative 2. And then I get negative 10. And I'm always kind of glad when I see a 0 there. It means there's no remainder. I guess it doesn't make a difference, but it's nice when they divide in evenly. Okay, so now if we're going to write down what does this mean, notice how this was our x to the fourth, x to the third, so on and so forth. So these are all 1 degree less. This is my x to the third term, this is x squared, this is x, this is my constant, and if I had anything there, it would be my remainder. So I can just go straight to writing down my answer, which looks like negative 1x to the third minus 5x squared minus 4x minus 2. So even for problems that start out kind of long, it's way quicker than long division. You just can't always use it, only for these single linear factors.